Hello, everybody. This is Shankar from System Based Labs. Welcome back. So far, we have gone through something very powerful. We understood how systems evolve from automation to intelligence to autonomy. And in the last video, we walked through how an enterprise agent system actually works. But now, we move into something more real. Because understanding architecture is one thing, building it inside an enterprise, that is a completely different challenge. So let us approach this the way a system architect would. If I were asked today to build an enterprise grade agentic system, where would I begin? Not with AI, I would begin with the problem. Because systems are not built around models, they are built around outcomes. Let us imagine a scenario, a customer onboarding system. In most organizations, this process is fragmented. Documents are collected, data is verified, rules are applied, approvals are routed, and everything is stitched together using workflows. But the moment complexity increases, these workflows begin to break. So instead of asking, how do I automate this workflow? I ask a different question. What is the outcome? The outcome is simple. Onboard the customer accurately, securely, and quickly. Now, once that intent is clear, the architecture begins to take shape. The first thing I need is a way for the system to understand requests. This could be an API. It could be a user interface. It could be an incoming document. But whatever the entry point is, it must translate input into intent because everything downstream depends on that clarity. Now, once intent is established, the system must begin to think. This is where reasoning comes in. I need a component that can evaluate the situation, understand context, decide what actions are required. In practical terms, this is where I bring in a language model. It could be OpenAI, it could be Azure OpenAI, it could be AWS Bedrock. But I do not treat it as a chatbot. I treat it as a reasoning engine. Now, reasoning alone is not enough because every decision needs context. So I introduce memory. This is not just a database. This is where the system remembers past interactions, understands historical patterns, and builds continuity. In real systems, this could be a vector database. It could be Azure AI Search. It could be Pinecone or VV8. Now something important happens. The system is no longer reacting. It is thinking with context. But thinking is not useful unless it leads to action. So now I connect the system to tools. These tools represent real capabilities. They could trigger an RPA workflow. They could call a backend API. They could interact with a database. This is where orchestration becomes critical because the system is not executing one step. It is coordinating multiple actions, and this coordination must be structured. So I introduce orchestration layers. This could be LangGraph. It could be AWS step functions. It could be Camunda. Now the system has intent. It can reason. It has memory, and it can act. But we are still not ready for enterprise deployment because something is missing: control. In real environments, systems must operate within boundaries. So I introduce guardrails. Every action is validated. Every decision is checked. Every output is controlled. This could involve policy engines, validation layers, compliance rules. Now the system is not just intelligent, it is safe. But even now, there is one more layer that defines enterprise systems: visibility. Because if you cannot see what the system is doing, you cannot trust it. So I introduce observability. Every action is logged. Every decision is tracked. Every outcome is measured using tools like Splunk, Elastic, Prometheus. Now the system becomes transparent. And this is where something powerful happens. The system begins to improve because feedback flows back into the system and decisions become better over time. Now let us step back. What have we actually built? Not a workflow, not a chatbot, but a system that understands intent, reasons with context, acts through tools, operates within boundaries, and continuously improves. Now this is where most people stop. But an architect cannot stop here. because reality always intervenes. So let me tell you what actually breaks. Latency becomes a problem because reasoning takes time, because every decision involves computation, and sometimes the system makes mistakes. Not because it is broken, but because it is probabilistic. So we designed for that. We introduce human oversight, not for execution, but for control, approvals, escalations, interventions. Now the system is not isolated, it is governed. And finally, we decide where this system lives. Cloud, hybrid, on-premise, each choice has implications. Security, latency, cost. So architecture is not just design, it is trade-offs. Now, if I bring all of this together, this is what I would deploy. An enterprise agent system that does not follow instructions but pursues outcomes. And this is the difference between building AI and building systems. So as you move forward, do not think in terms of tools, think in terms of architecture. Do not think in terms of automation, think in terms of outcomes. Because the future will not be built by those who connect APIs. It will be built by those who design systems that think, act, and evolve. We will see you in the next video. This is Shankar from System Based Labs. Good luck and go build systems that actually work.